Hey everyone, this is our last video covering review for this quiz. This particular review is covering the same standard. It's about graphing, but it's pointing out some important features and how graphs may look like we may not expect. So great, so let's jump right in. The graph of this is shown at the right. It says consider the rational function h given by that. Okay, so Raphael argues that this graph is identical to the graph shown, or x squared minus 4. So this is x squared minus 4 here. Y equals, that's the graph we're looking at. And he's saying that this other thing, that function, should look the same. Is correct. How could you reach it? If not, what is the correct graph? Explaining our reasoning. So let's look at, we just learned how to sketch these, so let's go ahead and use our process that we learned. So here's my standard form. 4x over x, and I know that my factored form, I could write this in factored form. I have an x in common in both of these, so I'm going to pull it out, get an x squared minus 4 all over x. And I could go to factor it more. It's not going to be super useful for what we need right now, but just so you know, you could factor more. This could factor into x times x plus 2, x minus 2 over x. Great. So we have that. Now the first key feature that we've been finding is our domain, right? Are there any values of x that would make us divide by 0? Let's look. From my factored form, sure enough, there's a term in my bottom, so I know x cannot be equal to 0. If it were, I'd be dividing by 0. That would be a big problem. Then I usually decide, is it an asymptote or a whole? Because I can remove it, there's a common factor of x on top and bottom. This is going to be a whole at x equals 0. Okay, so we've done some analysis. We see now that our graph's going to look like, x squared minus 4, except, because that's what it simplifies to, except that we have a whole at x equals 0. So we've done some analysis. We didn't even have to go through all the graphing. We just looked into it a little bit. And let's see what we can answer with this question now. So we're trying to answer, is he correct? Yes or no. So this graph that he's showing here, I'd say is not correct because it should have a whole right there at 0. So I can start by just saying no. X equals 0 is not in the domain of h of x, and there should be a hole in its graph at x equals 0. So we answered the question, is he correct? No. We've shown some work how we got to derive at the hole. And then what is the correct graph of y equals h of x? That is, well, it would be, we described what it would be. There should be a hole in its graph at x equals 0. And then we could also show that in our picture, draw an arrow or something, and just say, like, yep, should be a hole here at x equals 0, not a solid line value. So it's actually interesting because I made a mistake in our last example right at the end. We'd done great work and decided that there was a hole at x equals 3. Let me pull back that example. There was a hole at x equals 3. Yeah, right here. Go up. But I never put it in the graph. So I had just done my graph like this, making our sketch, and I'd gotten all the discontinuities except that there was a hole at x equals 3. So I should have gone over here and made sure I added back in a hole at x equals 3. To make it look like that. So it's interesting that that question was part of our review, but also, like, I forgot to do the exact thing that that person in our example was forgetting to add the hole where he needed it. So there it is. There's one more practice problem for that last skill of identifying the graphs, and then you should be all set for what's on the quiz and to show your mastery for these two standards, for graphing and for arithmetic.